Hello everybody. This video is your first introduction to logarithms. So we're going to go over this quite a bit. This is a pretty tricky topic, so bear with me. I promise you it's a little crazy and confusing at first. You will get it. What I have here is basically the definition of a logarithm. Okay, this is what a logarithm means. And this is the notation for it. Log, and this right here is referred to as the base. Okay, and just like your exponential, this is also referred to as the base, which you already knew that. So the log base b of y equals x is true if and only if, that's what that means, b to the x equals y. So basically what I want you to understand is when you have something like log base 3 of 9 equals 2, what that means is, if I rewrite that in exponential notation, this is logarithm notation. Exponential notation looks like this. I'm going to put these arrows here for a reason. Okay? It's 3 to the second power equals 9. That's what I mean by a logarithm is an exponent. A logarithm is an exponent. Okay, that's what it is. A logarithm is an exponent, and this is how we're going to be able to use logarithms to be able to solve problems that have unknowns in the exponent. Okay, so you're going to get the hang of this, but this little circular thing, hopefully you'll get the hang of converting a logarithm to an exponential, which you understand this. This is something that makes sense to you. I know this is a little bit weird at first, okay? So we're going to do a few of these examples, and I'm going to have you try a couple. So what I need you to do is convert these into exponential form. So you're going to use my little circle method here. So it's 2 to the third power equals 8. And you know that's true, right? 2 cubed is 8. Okay, that's what this means. So the log base 2 of 8 is 3. 3 is the logarithm. Okay? Here we go. This one is 4 to the x power equals 1. Well, what is 4? What is 4 to what power is going to give you 1? There's a very special number that does that. Hopefully you remember. It's 0. 4 to the 0 power equals 1. So this x right here is 0. The log base 4 of 1 is 0. Okay, let's try this one. 12 to the x power equals 12. So you guys know this. 12 to what power is 12? Yes, x is 1. Okay, 12 to the first power is 12. Okay, so basically you have to remember that a logarithm is an exponent. You got to remember that, okay? Can I say it again? A logarithm is an exponent. Okay, now I want you to try these. So why don't you try to rewrite these in logarithm form, okay? Give this one a try and this one a try on another piece of paper. And then when you get to this one right here, see if you can figure out what this would equal and type it into the space to the side. Okay, now let's see what happened here. Let's see how you did. We change this to exponential form. We have 3 to the third power equals 27. Okay, we know that's true. 3 cubed is 27. Here we've got 12 to the second power equals 144. Remember? A logarithm is an exponent. All right. Here, hopefully you got this one right. This would be 3 to what power, unknown, equals 81. You might have had to do a little guessing and checking, because what 3 squared is 9, 3 cubed is 27, and 3 to the fourth is 81. So x would equal 4 here. So hopefully you got that. Remember, x would be 4. A logarithm is an exponent. All right? This one is going to be a little bit trickier for you, so I'm just going to work through this one with you. Okay? This one is 10 to what power equals 0.001. Now you might have a little trouble with this because this is a decimal and it's a little confusing to you. So I would rewrite this as 1 over 1,000, because that's what that is, 1/1000ths, correct? So that's 10 to the x power. Now we know that 10 to the third power is 1,000, right? But what would give you 1 over 1,000? That's where a negative exponent comes in. So if you take x, if x equals, instead of 3, if x equals -3, that would give us 1 over 1,000, because 10 to the -3 power equals 1 over 10 to the third power, and that equals 1 over 1,000. So that's a little bit trickier, okay? You have to use the negative exponent there. Okay, a couple more things. Some vocabulary. A common log. A common log is base 10, okay? This is what is used most commonly, and before we had these amazing calculators, all of the logarithms that are now calculated into your calculator that are all stored in there, you used to have to look them up in tables. So you would look up logarithms, and they would only have base 10 logarithms in the back of the book. So this is called a common log, and it's base 10. So if you do not see a base here, if there's no number here, it's automatically assumed to be 10. Okay, that's a common log. Now a natural log is a base e. Okay, e is the number we talked about in section 4.2 or 4.3, excuse me. That very special number that you discovered and we worked with the continuous compounding interest. Okay, so if natural log, this is the notation for natural log. L for logarithm and N for natural, or some people say for Napier, who was actually the person who discovered logarithms. So it's the base e, but you won't see it written like this. You will only see it written this way. Okay, and that basically means that e is the base of your logarithm. Okay, so let's just try a couple really quick. Okay, so go ahead and try these, and I want you to put these in your calculator. The first two I want you to actually put in your calculator. You type in log, and on your TI Inspire, what it'll do is it'll put a little blank space here and a blank space here. Okay, you don't have to put anything there if it's base 10. It'll automatically assume it's base 10, and then you would type in this number. So go ahead and type that in your calculator, and then you're going to do the same thing, but you're going to use the natural log button. So find the natural log button on your calculator. Okay, and then this one, see if you can do that one without a calculator. So go ahead and give those a try. Okay, so this one, if you plug this in your calculator, hopefully, use a different color, you should have gotten negative 0.071. And for this one, you would have gotten 3.091, and that would have been, and what that means is that e to the 3.091 power equals 22. Okay? So did you figure this one out? This one is, remember this is base e. So e to what power gives you e? E to what power gives you e? Well, that would be 1. Okay? So hopefully this is a good little introduction to logarithms, and we're going to be working really hard on these for the next few days.